Okay, let's talk about queries. What are queries? Queries are just basically a mathematical expression, if you will, that extracts certain records from a map or a table. And it does this by one of two basic general functions. One is a spatial function and one is an aspatial function. So we call these aspatial queries and spatial queries. Aspatial queries have to do with the properties associated with an item in a database, like a count or a value or a category or some bit of information that deals with an individual parcel. And so you set a criteria, and then it goes through the database and it finds all the individual things in the database that meet the criteria you establish based on properties. And then there's spatial queries. And basically, these have to do with a physical location of the items. And again, just like with other query, you set criteria for what you're looking for. Like this parcel is within the distance of this, or it is inside of this, or near that. And then based on physical location, that's how spatial queries work. So let's look at how we can use this, for example, to select features of interest. Here we have a vegetation layer, cover type, and one of these is aspen stands. And so we can simply go through and select, all the land cover types that are aspen. It will then highlight those on the data set, and we can then calculate all various number of statistics because those are the only ones selected. We can also use this to query patterns, to explore patterns. So are aspirin stands randomly scattered or clustered? Do they occur in particular portions of the forest? What are the distributions of the stand densities? We can, once we identify the various stands, we can look at the physical configuration for where they're located and all these other things. And it's really hard to do that if you don't isolate that data from the other stuff. In other words, if you don't query out just the forest type you're interested in from the others, it makes it difficult because once you do that, you can, in this example, we can symbolize it with colors based on another field. You can also isolate subsets of things for other analysis. For example, if you look at the tree size or the density, you can use this to select a subset of the subset that you might want to do more analysis on. You can also use queries to help explore spatial relationships. Things like what fraction of the stands are intersected by roads, what types of trees are adjacent to the aspen stands. All these are things that you can look up and identify using various queries. Some queries involve surfaces. For example, in your class project, the flying squirrel habitat model, we use an elevation layer, knowing that the squirrel's habitat preferences are above 909 meters. And so in that scenario, you could do a query of a data set to select just the elevations above that and generate from that specific data sets. And there's lots of different ways you can utilize things like this. Let's look in more detail at attribute queries. Attribute queries use a special query language called structured query language, SQL. It can write queries that work in multiple database management system environments. You can save them and reuse them. The thing about these is they're almost always case sensitive and definitely spelling sensitive. And so you have to know exactly what things are labeled, how they're labeled, and punctuated in order for these queries to work properly. One of the things that ArcGIS software does that sort of helps with this is they have these GUIs, these graphic user interfaces. In this case, we're looking at the select by attributes, which is simply a query, a SQL query interface from which you can select what you want to do, like create a new selection or select from an existing selection or add to an existing selection. You select the field of interest. You have the mathematic functions there. You can get the unique values and just simply click and select instead of typing. And it converts all these options and things that you're asking it to do to populate a SQL expression that will then select the data that you're looking for. Queries also act as sets. Here we have these different data sets, and one is all the students in a university, students from New York, geography majors and English majors, and queries can select subsets of data based on multiple criteria. And the example they use here is geography majors from New York. New York being the red circle, geography majors being the B circle. The geography majors from New York are the areas that overlap between circles A and circles B. Single criteria are really simple. Um, but to find out more complicated things, it's a little more tricky. I already did the example of double criteria, New York and geography, and you can see that there's only that area of overlap, and that would be those students. And versus or. If each condition is tested separately, if the and function is used, then both must be true. If the or function is used, one or the other must be true. So when you're doing functions like you're looking for home state equals New York or New Jersey, then if they're from New York or New Jersey, they would be selected. If you use the and function, they would have to be from New York and New Jersey, which would be kind of hard to do since you can really only be from one place. Boolean expressions are the classic 1, 0, yes, no, binary, true, false kind of statements. And they're super helpful for modeling purposes, especially if you have criteria that there's no real weight function associated with it, or classification function. It's either okay or it's not. It either is allowed or it's not. And so for a lot of modeling purposes, there are a lot of times things that you just can't do. Like you can't build a home in a residential zoned or in a retail zoned area. If it's zoned for retail, you can't have residential. And so it's very simple. If you're looking at where you can build houses, it's either okay or it's not okay. It's 1 or it's 0. It's binary. It's a Boolean kind of expression. So there's all these other examples here, and I'm not going to spend too much time on them, but you can take the slides and sort of look through this a little bit more, and it'll make some sense in terms of thinking about just look at the question and whether the function is an and function or an or function, and then relative to the circles up there, try to decide what you think the right answer is. Again, simply going from an and to an or, instead of the overlap, it's basically everything that's in A and everything that's in B. So think about these various things. Pause the video if you like and look at it. Try to figure out where you think these things are. It's good practice. Again, a whole more data sets worth of questions here. Just take your time and look over the whole set. Do more. No, when I said whole more, that's what I mean. Look at the whole set. Do more attempts on your own to think about A and B or A or B and what that means relative to these different data sets. There's other Boolean functions, not just and or. There's the A, X, or B, and the A and not B. And so one looks for stuff that's in both data sets, but not that's in either data set, but not both. And one looks for everything that's in one, but not in the other one. These are complicated and rarely used, but when the time comes that you need to do something like this, they work really, really nicely. It's just a matter of then remembering that, oh yeah, this is an opportunity to use that function. So again, pause your video and watch or read rather down through this list of A's and B's, A's or B's, etc. Using the key on the left there for what each of these circles mean, and then try to visualize what you think they should look like. I want to talk a little bit about the commutation of operators. And remember that the and the or and the not or are commutative. In other words, they can go either direction. It means the exact same thing. But you have to remember not is not commutative. So if it's got the A not B, that's not the same as B not A. Order of operations is also a key element to this to remember. Basically, Boolean operators have an equal order of precedence. Evaluations always occur from left to right, and parentheses must be used if you want to change that order. So if you don't want to strictly go left to right, then you have to put parentheses around things. More of these diagram examples for you to think about how the parentheses play into what is what. So again, good opportunity to spend more time to look at these examples. So pause the video, read down the list, interpret what it says, and visualize what it means. So some basic tests you can do if you're trying to make sure you understand this. Think about the and versus or. So land use equals RES and land use equals COM versus land use equals RES or land use equals COM. Population greater than 5,000 or population less than 9,000, population greater than or equal to 5,000, and population less than 9,000. Very sort of maybe different things. So you need to run through that and think about what that is identifying. Because some of these work and some do not. Multiple conditions. You want to test these. Test using these parcels that you have here and look at where the parentheses go and what that does to the final output. Remember, you go left to right inside parentheses first. You can also use what they call wildcards to search for partial matches. This shows some demonstrations here as you work through the text in the the tutorials in the price text. She will have you doing some of these, and they'll make a lot more sense at that time when you do those actual exercises. So how does that all work? Why would you use that? For example, you have a name field like this where you have the name of politicians, and then following their name in parentheses you have their political affiliation, and what you're trying to do is sort out the Democrats from the Republicans. That's a really hard thing to do, but you can use sort of some of those specific search things to find stuff, and use some of those wildcard things, and it will make it so that you search more specifically. Again, textbook tutorials will give you really solid examples where you'll get an opportunity to do this kind of stuff in the software yourself, and then when the time comes that you have to do a search like this, you'll know how. You may not remember how exactly, but you'll know where to go back in your textbook or your notes to refresh on this, and that can be a skill that will help you for years to come.